Hello students. In last video, we have seen a very basic concepts of advanced machine learning starting from unit 1, that was neuron. Another name to neuron is known as perceptron. So today we are going to continue our video with perceptron, and that is what the second concept of unit 1. So perceptron is same as your neuron. It is a basic building block of neural network. It is invented by scientist Rosenblatt, and the working of the perceptron is same as your neuron. That is, you will have input as xi, which will be multiplied to assign the weight wi. Then that product is known as a weighted sum. So this weighted sum will get the value added, that is what the bias, and finally whatever value you are getting, that value should be compared with one threshold. Now here let us consider the threshold as 0. When your weighted sum is greater than that threshold, then you will get your output as a 1, and otherwise you will get your output as a -1. So when you are getting only two outputs, then such classification is called as a binary classification. So perceptron we are mainly using for binary classification, and when our activation function is comparing our weighted sum with 0, then such type of the activation function is called as a step function. So perceptron working is mainly based on step function. Now, so what is your Wixi? That is your scalar product, that is your weighted sum. Now, here we can see our input as 1 to n. But while taking the value of I in your summation, you are putting it as a 0. So what is your x0? What is your w0? It is playing the role of a bias. Okay, so bias is used to give better accuracy for your neural network. Now, here, what I told you, we are using a step function where we are comparing our weighted sum with 0, and when this condition is satisfied, you will get the output as +1, otherwise your output will be -1. So that you can see very clearly here, that is in the form of a step function. Means when your weighted sum is above 0, then you will proceed in positive region. Otherwise, you will come back to the negative region. So such working is called as a threshold logical unit. Now, in the name, we can see that it is a linear threshold unit. Now, why the linear word has came into picture for perceptron is mainly used for linear classification. So, perceptron we are using for binary classification, and it is capable of dividing your data only linearly. Means you can create a model which is dividing your data by a single line if it is a 2D, and if it is more than 2D, then in that case for division you have to use a hyperplane. Okay, so that is what here given. When your inputted data points are 2D space, then you are capable of dividing those data points in two classes by using a single line. But when you are going for n-dimensional space, then in that case, you have to make use of a hyperplane. Okay. Now, what this diagram is telling you that your input you can divide into two classes S1 and S2 by making use of a single line. Okay, but consider the second case where you are dividing data by using a non-linear line. So such input is known as a non-linearly separable pattern. Now, let us consider one example. Now, when we are looking in our AND gate, then when you are having both values as +1, then only it is +1. If any one value is negative or both values are negative, then your AND will have a 0 output. Okay, so can we model our AND gate using perceptron? Yes, it is possible. Means I can plot a line like this, where all my remaining three outputs, means when one of the input is negative or both the inputs are negative, then I am getting the -1. so that I can put below the line. And when my both the inputs are positive, I'm getting a positive output that I can represent by the area above the line. So AND gate is linearly separable. Now let us see what is OR gate is saying. OR gate is also capable of separating your data linearly, but XOR is not at all doing that one, because in XOR, when you have two same values, means when your data is representing even parity, then it is 0. But when it is odd parity, it is 1. Now, here, when it is even parity, then these 2 points are active. And when it is having a odd parity, then in that case, these 2 points are active. So is it possible to use a single line to separate such kind of data? No. Okay. So we can represent only AND or in complement gates, means a data that is linearly separable using perceptron. But we cannot model XOR function because it is non-linearly separable. Okay. So this we have seen that here we have to consider threshold as 0. And when it is greater than the threshold, then only make it as a 1. Otherwise, it is a 0. So what do you mean by single layer perceptron? In single layer perceptron, no, you are having only one input layer and one output layer. Now, in layer, you have to take inputs from xi to xn. And you will get the output from yi to ym, and your weight will be wij. Okay, means first you have to consider your input and then your output. Okay, so such perceptron is called as the single layer, in which you are having only one input layer and only one output layer. Now, how to create? What is the algorithm to create such single layer perceptron? Now, what you need? You have to calculate a scalar product. Now, for my scalar product, I need two input. One is a x, second one is a w. Now, x is already given by user. Now, I have to initialize vector w. Okay. Then I have to get my weighted sum. Now, I have to compute my output using a step function. Hence, I have to decide some threshold value and I have to compare the weighted sum with that threshold value. And based on that, I will generate my output yj. Okay. Now, small yj will be my target output. Means there are two kinds of the output. The output that we are getting by using the single layer perceptron, and the output that is a desired output. The difference between these two will be called as a error, and the target of neural network will be always to minimize that error. Okay. Now, when that error is 0, means your data is classified very correctly. The accuracy of model is perfect. Then in that case, you can just display the weights and the output and you can exit. But when the difference between the expected output and obtained output is more. For example, listen, my expected output is 1, but I'm getting only 0. Then in that case, I should decrease the value. Then how I will decrease it? I will modify the weight by using the formula Wi minus alpha xi, where alpha is known as a learning rate. Okay, but when I am expecting the output 0 and I'm getting it as 1, means what? I have to increase from 0 to 1. Then in that case, I will increase the weights. Okay, means instead of minus, I should use the plus. So alpha is a learning parameter and that is constant. And then again, whole process I have to repeat with these new weights. So this is the algorithm for your single layer perceptron. So in today's class, what we have seen, how perceptron works. The working is same as your neuron, but the another name for the perceptron is linear threshold unit, because it is capable of dividing your linearly separable data. Okay, and if that data is 2D, then it will use a single line. If it is more than 2D, then it will use a hyperplane. And what is the algorithm for single layer perceptron? That also we have seen, and we have tried to apply the perceptron on 3 gates and OR and XOR. And what is the conclusion? It is capable of dividing the data for and OR gate, but not for XOR gate. Thank you.